How do open-loop versus closed-loop op-amps function in electrical engineering? Have you ever wondered how operational amplifiers work in different configurations? Today, we will break down the differences between open-loop and closed-loop operational amplifiers in a way that is easy to understand. Operational amplifiers are essential components in analog electronics, primarily used to amplify voltage signals. When we talk about open-loop operation, we refer to using the operational amplifier without any feedback from the output back to the input. In this mode, the operational amplifier has an incredibly high gain, often reaching 100 million. This high gain is known as open-loop gain. Due to this immense gain, even the slightest difference between the input terminals can cause the output to quickly reach the limits of the power supply, either positive or negative. This means that open-loop operation is not practical for linear amplification of signals. The output saturates for almost any input other than very close to zero. Because of this, the open-loop configuration is mainly useful for applications like comparators, where the output switches between saturation levels based on the input polarity. Now, let's talk about closed-loop operation. In this configuration, a portion of the output is connected back to the input through a feedback network, which usually consists of resistors. This feedback reduces the overall gain to a controlled and stable value, known as closed-loop gain. Unlike open-loop gain, closed-loop gain is mainly determined by the feedback network components and is largely independent of the operational amplifier's intrinsic gain. This feedback loop stabilizes the amplifier, allowing it to operate linearly over a broader range of input signals. The feedback helps correct the output to maintain the desired gain, which improves accuracy and bandwidth. Closed-loop gain can be designed to meet specific amplification needs by adjusting resistor ratios in either inverting or non-inverting amplifier configurations. From an electrical engineering perspective, the differences between open-loop and closed-loop operation are vital for practical circuit design. Open-loop gain is very high but unstable and nonlinear for most input signals. This limits its use to specific applications like comparators. On the other hand, closed-loop gain provides controlled, stable, and linear amplification by using negative feedback. This not only extends bandwidth but also reduces distortion. The frequency response also varies between the two configurations. Open-loop gain decreases rapidly with frequency, which limits bandwidth. In contrast, closed-loop configurations trade some gain for improved bandwidth and predictable frequency behavior. To summarize, open-loop operational amplifiers function as high-gain devices that saturate easily, making them suitable for switching or comparison tasks. Closed-loop operational amplifiers utilize feedback to achieve precise, stable, and linear voltage amplification, which is essential for analog signal processing in electrical engineering and embedded systems.